Hello, in this episode of Your Salvation, I'm just making a joke, it's not really an episode. We're going to calculate the odds ratio and 95% confidence interval, and then the relative risk and 95% confidence interval. Two different ways of doing the same problem. Let's start with number 2 here. Table 2 presents data on the relation between socioeconomic status and marijuana use. For SES, or socioeconomic status, we use free or low-cost lunch as a proxy. So if you have low-cost lunch, we're assuming you have lower socioeconomic status. Thus, we were interested in whether individuals who used marijuana in the past 30 days received free or low-cost lunch. Your job is to calculate the odds ratio, a 95% confidence interval, to see if individuals using marijuana in the past 30 days were more likely to have received free or low-cost lunch than individuals who did not use marijuana in the past 30 days. Make sure to interpret the results for the normal folks amongst us. So here are your data. So the columns are used or did not use marijuana in the past 30 days, and the rows are free or low-cost lunch, yes or no. So this is kind of like a case control study in that we have status, like disease status. In this case, marijuana would be equivalent to disease, although it's not a disease. And we're looking at exposure as a predictor. In that case, we could use an odds ratio. Okay, so let's go ahead and do that. So I have the output written out here. Let's see. All right. So the odds of any event occurring are the probability of success divided by the probability of failure. This is binary, so having success or failure would equal to a probability of 1. So it's an either-or scenario. The two are mutually exclusive. We define success as whatever we're interested in. In this case, it's yes for free or low-cost lunch, and failure would be no. So I know that doesn't make sense necessarily in terms of the way we would consider success and failure, but in statistics, we always think of success as whatever we're interested in predicting. The odds ratio is just a ratio of odds. So in this case, we're looking at the odds of free or low-cost lunch among those who use marijuana versus the odds of free or low-cost lunch among those who did not use marijuana. So it's a ratio of those two odds. So when we calculate it, you'll see here, appealing to our table. Let me get to the right table here. So these are the individuals who used marijuana, and among those, 45 had low SES based on free or low-cost lunch status, and 15 didn't. So success would be these 45, and 15 would be the failures. So I noted them as probability, but to get the probability, we divide by totals, but we're just not going to do that. So we can just use the actual values within each of these different cells. So for those who did use marijuana in the past 30 days, we have 45 individuals for low SES versus 15 who were not. So that's our numerator, and our denominator is the odds of having free or low-cost lunch among those who didn't use marijuana. So we got 617 over 931. When we bring the denominator into the numerator, we just flip it around. So we get 931 over 617. So we get 415 times 931 over 15 over 617. And we got a really large odds ratio here. So this obviously means that individuals who used marijuana are much more likely to be lower SES. Actually, they're almost 42 times more likely, excuse me. So to calculate our confidence interval, we have to exponentiate. And the reason we do this is because we have to take the natural log of the odds ratio. The odds ratio itself is not, although it's not quite, doesn't quite fit a normal distribution, It's skewed, so in order to correct for the skew, we take its natural log. So natural log means its base is E or Euler's number. So we go ahead and do that, and then we add and subtract the standard error from that, or excuse me, the margin of error from that. The margin of error, in this case, since we're taking a 95% confidence interval based on a standard normal distribution, the z-value for an alpha of 0.05 and a 95% confidence in alpha is the probability of a false positive result. Those two are mutually exclusive, so that's how we get the 95% confidence interval. So the z-value associated with that is 1.96, right, in either direction, because we say plus or minus because we can be above or below a confidence interval surrounds our point estimate, and our point estimate here is the odds ratio. So we have to multiply 1.96 times its standard error, which is the square root of 1 over, and these are the different cells in a 2x2 cross tabulation, 1 over A plus 1 over B plus 1 over C plus 1 over D. And when we do that, you'll see we take the natural log of our odds ratio, and we do 1.96 for the margin of error times the square root of all these different numbers here. So these are the different cell values. And when we calculate that, we get, so we're dealing with the natural log. So at the end, we have to exponentiate to return everything back to the odds ratio, back to the odds ratio. So it's e to the, so the natural log of 41.747 is 3.732. And then we add and subtract 1.96 times the standard error, which is 0.3026. And in the end, it's 3.732 plus or minus 0.5932. So we do this for the lower limit of the confidence interval and the upper limit. We get this really nice and wide confidence interval. So that means something. First of all, our odds ratio is pretty large, but also we have some disparity in the values within the cell, the number of individuals within each cell. So how do we interpret this? Adolescents using marijuana in the past 30 days are nearly 42%. Again, so we had 41.747, so that's, excuse me, so I should say 42 times, not 42%, that's my mistake. It's 42 times more likely. So I'll have to correct that. 42 times more likely, not percent, more likely to have received free or low-cost lunch than adolescents not using marijuana. And this relation is significant, and the reason it's significant is because it does not include 1. An odds ratio of 1 would mean that the odds of exposure and not exposure, the odds of exposure among those who use marijuana over the odds of exposure among those who didn't use marijuana would be exactly the same, so there'd be no difference. So that would be an odds ratio of 1. So since this confidence interval does not include 1 in it, and it's way above 1, we could consider this a significant effect. So it's significantly different from 1, an odds ratio of 1, which means there's no relation between marijuana use and socioeconomic status. Okay, so let's go to the next problem here. The next problem is just kind of like a permutation of this. It says, suppose instead of the results of presented in Table 1 represent a cohort study comparing suppose instead the results presented in Table 2 represent a cohort study comparing low and higher socioeconomic status adolescents on their development of marijuana use. Calculate the relative risk. So relative risk can only be calculated in a cohort study where we're moving forward from exposure to disease outcome. That's because risk is synonymous with incidence, and incidence means the number of new cases. You can't have new cases when we're doing a case control type study, but you can have new cases in a cohort study where we start with different levels of exposure. So if we imagine this as being some kind of a prospective study, longitudinal study, where we compare those who have and those who do not have free or low cost lunch or low socioeconomic status, and we see which of them would have started using marijuana in the past 30 days. So that's what we're doing here. All right, so let's look at this instead. So let me increase the size here a little bit. Let's go up to, say, 4. All right. So relative risk is the risk among the exposed divided by the risk among those who are not exposed. Risk is in a sense is a proportion. So we take the number of individuals who become marijuana users in the past 30 days out of the total among those who are low socioeconomic status, and we get 0.06798, or like there's basically 7% of them. So if we look at the table, so that's 45 divided by 662, right? So what it's the proportion of those who become marijuana users. I guess we call that an incidence proportion, to be honest, or to be more accurate, I should say. And then the risk in the non-exposed, right, who are not exposed to low socioeconomic status is 15 over 946, or 0.01586, and we take that ratio, that's the risk ratio, and it's or relative risk, it's 4.286. So we do the same thing here. We have the same issue as before, where we have a lack of a normal distribution, so we natural log transform in order to make it more normal in appearance, and again in the end we have to exponentiate to return it to its relative risk scale, and we add it and subtract the margin of error. In this case, the only difference is that our standard error is calculated differently. It's 1 divided by the proportion, and the proportion here is really the risk in the exposed divided by number of individuals who are exposed times the proportion exposed. And it's interesting that this value here is actually going to be the number in a given cell, right? So for instance, for those who are exposed, we have 1 minus 0.6798, and it's divided by 45, which was the number of individuals in the first cell here, in cell A, right? Because they're the number who are exposed who are marijuana users. And the same occurs for those who are not exposed who are marijuana users. We'll see that their cell number becomes the denominator in the second part here. Okay, so we go ahead and take the natural log of 4.286. We have 1.455, and then we add and subtract as we do in any confidence interval, because it surrounds a point estimate, whatever that is. And the point estimate here is this natural log, which is 1.455. And we get 2 different values, which we exponentiate in the end to return us to the relative risk scale. So how do we interpret this? So receiving low or reduced cost lunch is associated with an over 4.25-fold increase. This is 4.286. So that's 4.25 would be 4.25. So it's over a 4.25-fold increase. And I always make sure that you write down the relative risk and the confidence interval for your reader and the risk of using marijuana in the past 30 days. Okay, I really hope this helps everybody to do well on your extra credit or your salvation item. Thank you.